Welcome back, everybody. We're now going to look at going from names to formulas. Hopefully you'll find this a little bit easier than what we've been doing. Let's take a look at some examples here. We'll start off with aluminum fluoride. And if we look at the chart, we'll get A, L, and F here, but we've got to figure out what the charges on these guys are. So we go back to page 2 of the survival guide, and you'll see that aluminum has a 3 plus charge and fluorine or fluoride has a -1 charge. So we put those on here. And the question we've got to ask ourselves is, how many of each do we need in order to make the positives and the negatives equal? And hopefully you can see that we would need 3 fluorines or 3 fluorides to get a -3 charge. That would match for 3 plus charge on 1 aluminum. So our name or our formula would be AlF3. 1 aluminum and 3 fluorides to make the charges even out at +3 and -3. So we're good to go. Okay, let's do another example. Alright, let's see, copper 1 phosphate. Alright, so we know from what we learned earlier that the 1 here refers to a 1 plus charge on the copper. It doesn't mean there's only 1 copper. It means there's a 1 plus charge on the copper. So we've got Cu plus. You've got to figure out phosphate. So what we do is we go to the polyatomic iron sheet, which again is in the back of your module. Phosphate. Here it is. PO4 3-. So write that down. And again, the question I want to ask is, how many of each do I need in order to make the positives and the negatives equal? And I hope that you can see that we would need 3 coppers to give us a 3 plus charge to match for 3- charge on the phosphate. So our name or our formula here would be Cu3PO4. Right, that means we need 3 coppers to give us a 3 plus charge and 1 phosphate to give us a -3 charge. Remember, that's only 1 phosphate. That's not 4 phosphates. That is just the 1 phosphate there. And that is our formula, Cu3PO4. Let's do another example. Magnesium phosphate. If I look at page 2, I'll find that magnesium has a 2 plus charge. If I look at the polyatomic iron sheet, I'll see that's phosphate, just as we did earlier. And now I've got to figure out a way to even out these charges. Now it looks pretty hard. We've got 2 and 3, 2 plus, 3 negative. So what are we going to do? So what we should do is use a similar concept to what we use in fractions, and that is to get a common denominator, or in this case a common charge. And if we multiply 2 and 3 together, that'll give us 6, and that's actually the common charge we're going to work towards. So we're going to work towards +6 and -6. If we want to get +6, then we're going to need 3 Mg2 pluses. Whoops. And we're going to need 2 PO4 3-, and that will give us charges that even out, which is what we want. And our final formula, Mg3, because we've got 3 magnesiums, PO4 2 for 2 phosphates. Okay, one more example. Lead 4 carbonate. So again, the 4 here indicates a 4 plus charge on lead. Not 4 leads, a 4 plus charge on lead. Pb4 plus is what we have. Carbonate of the polyatomic iron sheet, CO3 2 minus. Now what I want you to be able to see here is that we would need 2 of these so that we could get the charges to match 4 plus and 4 minus. So our final formula here would be Pb CO3, and we need 2 of those. So 1 lead to give us 4 plus and 2 carbonates to give us 4 minus, and there's our final formula, PbCO32. Well, there you go. Not too hard, I hope.